Hello students, myself is Parminder Singh from Prab Kirpa classes. Our today's topic is probability part 4. After going through this course, the students will understand that probability refers to the likelihood or chance of a particular event or outcome occurring. Probability is often expressed as a value between 0 and 1. If we say that the probability is 0, it means that the event is impossible to happen. If we say that the probability is 1, it means that the event is sure to happen. If the probability lies somewhere between 0 and 1, it shows the varying degree of likelihood of the occurring of an event. If we want to calculate the probability of an event, then the formula for the same is number of favorable outcomes divided by total number of possible outcomes. Probability axiom or probability bounds indicate that the value of probability always lies between 0 and 1. Probability of an event is always greater than or equal to 0. Then the probability of an event is always less than or equal to 1. That is, the probability of an event always lies between 0 and 1, both 0 and 1 inclusive. For any event, the sum of probability of happening of an event and the probability of not happening of the event is equal to 1. Is also used in real life situations such as weather forecasting and stock market investing. In case of weather forecasting, the meteorological department tells us the probability of the likelihood of the rain coming. If the prediction or the probability is that it will be likely raining, then we may make further decisions like whether we should carry umbrella with us or we should not go outside at all if the rain forecast is on the heavy side. In the same case, the probability concept is also used in stock market investing, because if there is the probability of rising of the stock price, the investors invest in the particular stock, and in the same way the concept of probability is also used in finding out the probability of likelihood of the risks which may incur if we invest in a particular stock. Then these are the few questions which we will solve in this course. Now the question before us is, two customers, Shyam and Ekta, are visiting a particular shop in the same week, Tuesday to Saturday. Each is equally likely to visit the shop on any day as on another day. What is the probability that both will visit the shop on same day? Here the words are on any day as on another day. It means that Shyam and Ekta can visit the shop on any day out of these 6 days. So the days are Tuesday, we may abbreviate it as Tuesday T. Then Wednesday, we can abbreviate it as W. Next is Thursday. For the purpose of solving the question, we are using abbreviation. For Friday, we can write it as F. For Saturday, we can use the abbreviation S. So both the customers can visit the shop on any day in between Tuesday to Saturday. So here we will write Tuesday, Wednesday, Thursday, Friday, and Saturday. So these are the 5 days. So here we will write Shyam. Here we are calculating the possible outcomes. That is, what are the chances that they will visit the shop on a same day. To calculate the same, we have to arrive at the total number of outcomes, and after that we will find out the favorable outcomes. This is the, for that purpose we have to form a table to find out the total outcomes as well as the favorable outcomes. This is Shyam. Here we will again write the days: Tuesday, Wednesday, Thursday, Friday and Saturday. Here we will draw rows. Here we will draw columns. We are drawing this table so that we may arrive at the total possible outcomes and the number of favorable outcomes, as the formula for calculation of probability is number of favorable outcomes divided by total number of outcomes. So if Shyam visits the shop on Tuesday, it is likely that Ekta may also visit on Tuesday. If Shyam visits the shop on Tuesday, it may be possible that Ekta visits the shop on Wednesday. If Shyam visits on Tuesday, Ekta may visit on Thursday. If Shyam visits the shop on Tuesday, Ekta may visit on Friday. If Shyam visits on Tuesday, Ekta may visit on Saturday. In the same way, if Shyam visits the shop on Wednesday, Ekta may visit on Tuesday. In the same way, we will form the whole table. That is, the first we will write Wednesday and it will be followed by the day which is written above the columns. Here we will write W. That is, if Shyam will visit Wednesday, it may be possible that Ekta may visit on Thursday. If Shyam visits on Wednesday, it may be possible that Ekta may visit on Friday. In the same way, here we will write Wednesday, Saturday. Here we will write Thursday, Tuesday, Thursday, Wednesday, Thursday, 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 Friday, Thursday, Saturday. Here, if it is possible that if Shyam visits on Friday, Ekta may visit on Tuesday, Friday, Wednesday, Friday, Thursday, Friday. Here we will take first F, then this. First we will take this, then Saturday. In the same way, Saturday, Tuesday, Saturday, Wednesday, Saturday, Thursday, Saturday, Friday, Saturday, Saturday. So now you can see that here the total number of possible outcomes are you may count 1, 2, 3, 4, 5, 5 into 5, 25. So now the number of favorable outcomes. Number of favorable outcomes means the same days, number of days which are same in respect of the visiting of Shyam and Ekta on a particular day in the said week. That is, if suppose Shyam visits on Tuesday, Ekta also visits on Tuesday. If Shyam visits on Wednesday, Ekta Wednesday. If Shyam Friday, Ekta Friday. So this is the same days. We will count the number of days which are same for both, that is Shyam and Ekta. You can find that this is the Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday. That is in this row. This is this. These are 5 outcomes. These are the 5 outcomes. So, probability, both will visit the shop on same day is equal to number of favorable outcomes divided by total number of possible outcomes. So, it is 1 over 5. So, we have been able to solve the first part. Now, we come to the second part. Here, we have drawn this table from the earlier part which we have already solved. So, now what is change in this question? What we have to find out? We have to find out what is the probability that both will visit the shop on consecutive days. Consecutive means if Sham visits suppose on Tuesday, what is the probability that it will also that the consecutive is the next day or the previous day? In this question, the days given are Tuesday to Saturday. So, in case of Tuesday, the consecutive day will be this Tuesday, Wednesday. In case of Wednesday, the first it will be Tuesday, Wednesday, or the consecutive days may be Wednesday followed by Thursday. In case of Thursday, it may be earlier day is Wednesday, then Thursday may be followed by Friday. In case of Friday, the earlier day is Thursday. These are also consecutive days. Next, in case of Friday, Saturday. This is also a pair of consecutive days. So, in this way, we have to find out the consecutive days. That is, days which are there is no gap in between 2 days. So, we will find out the same. So, here we find out that Tuesday, Wednesday, there is gap, there is gap, there is gap. Wednesday, Tuesday, there is no gap. Wednesday, Tuesday or Tuesday, Wednesday, it is the one and the same thing. Then Wednesday, Wednesday, these are the same days. Wednesday is followed by Thursday. These are also consecutive days. Next, Wednesday, Friday, there is gap of Thursday. Wednesday, Thursday, there is gap of 2 days. Thursday, Tuesday, there is gap of 1 day. Thursday, Wednesday, this is Wednesday, Thursday or Thursday, Wednesday, it is one and the same thing. This is the same day. Whereas we are talking about the consecutive days. Thursday, Friday, this is the consecutive days. That the days where there is no gap between the 2 days. Friday, Tuesday, there is gap. Friday, Wednesday, there is gap. Friday, Thursday, or Thursday, Friday, there is same. Friday, Friday, it is the same day, not consecutive. Friday, Saturday, these are consecutive days. Saturday, Tuesday, there is gap of Sunday. Saturday, Wednesday, there is gap. Saturday, Thursday, there is gap of Friday. Saturday, Friday, it means Friday, Saturday or Saturday, Friday, these are consecutive days. Saturday, Saturday, these are same days. So now we will count the number of favorable outcomes, that is the number of consecutive days. 1, 2, 3, 4, 5, 6, 7, 8. So here we will write total number of possible outcomes. We have already counted that 5 into 5, these were 25. Now the number of favorable outcomes or number of consecutive days, these are, we have counted 3, 4, 5, 6, 7, 8. 8. So the probability both will visit the shop on consecutive days is equal to number of favorable outcomes divided by total number of possible outcomes. This is 8/25. This is the answer of the second part of the question. Now we proceed with the third part of this question. Now here it is written, what is the probability that both will visit the shop on different days? Different days means other than same days. That is, these were the same days. Tuesday, Wednesday, Thursday, Friday, Saturday. These were the same days. Other are all different days. Tuesday, Wednesday, Tuesday, Saturday, Wednesday, Thursday, Saturday. All are different days. So we can solve it as total number of possible outcomes as 25. Number of favorable outcomes, we can write it as 20, because we will reduce the 25 minus 5 same days. We have arrived at by deducting 5 same days from total number of possible outcomes. So these are the number of favorable outcomes where the probability of visiting on different days. So here 20/25, it is 4/5. Here is the another way in which we can solve this question. What is that? Here it is written that we know that the probability of two complementary events is equal to 1. That the probability of two complementary events, it is written as probability of happening of the event and probability of not happening of the event is equal to 1. Here we have already solved in the first part of the question that the probability of happening of the same event if we say that the probability of happening of the event is probability of visiting on same day. If they are not visiting on same day, it means that they are visiting on different days. We can write it as P dot P. Here we write it as given probability of visiting on different days. So here we have already calculated that probability of visiting on the same day we have already calculated. What was that? We may see it was 1/5. So from this 1/5 plus probability of visiting on different days is equal to 1. So probability of visiting on different days is equal to 1 minus 1/5. It is 5 minus 1. It is 4/5. So you can also arrive at the question in arrive at the answer in this way. You can adopt either this way, this formula, or you can adopt this. That is the probability of an event plus probability of not happening of an event is equal to 1. When we have already calculated the probability of happening of the event, that is probability of visiting on the same day we have already calculated, we will subtract that from 1 and the probability of visiting on different days will be arrived at. Now the question before us is, a box contains 12 balls out of which X are black. If one ball is drawn at random from the box, what is the probability that it will be a black ball? If 6 more black balls are put in the box, the probability of drawing a black ball is now double of what it was before. Find x. That is, we have to find the number of black balls. So now first of all, we will write a box contains 12 balls. Total number of balls is given in the question are 12, out of which x are black. Number of black balls, these are given as x. So now, if one ball is drawn at random from the box, what is the probability that it will be a black ball? So the probability of getting a black ball is equal to the number of favorable outcomes divided by the total number of outcomes. Here, the number of favorable outcomes means the number of black balls, that is x. It will be divided by the total number of possible outcomes, that is the total number of balls. So here, the probability of that it will be a black ball is x over 12. So now, what is given more in the question? 6 more balls are put in the box. So now, total number of black balls are x plus 6 x, because 6 balls have been added, the black balls becomes x plus 6. Here we will remove total. So now total number of balls, here we will not write black balls because we are to add 6 here also. So the revised number of balls which are total are 12 plus 6. Here it will become 18. So now, what is the new probability of getting the black ball? So new probability is number of favorable outcomes. Here the revised number of black balls will be here mentioned. Here the total number of balls which have been revised, that is this 18. So here we have now arrived at new probability. Old probability is given here. So now here it is given that if 6 balls are put up in the box, the probability of drawing a black ball is now double. That is, here it is given that as per question, new probability is double of what it was before. That is, the new probability is equal to double of old probability. So now what is the new probability? New probability. Now we will fill in the value of new probability. What is new probability? It is x plus 6 over 18. Here 2 multiplied by old probability. What is the earlier probability? It is x over 12. So here we will solve it. Here it becomes x over 6. Now we can also write it as x plus 6 is equal to 18x divided by 6, or we can write it as x plus 6 is equal to, here we will divide it by 3, it becomes 3x. Here we can also write it as 3x minus x is equal to 6. That is 2x is equal to 6 for x is equal to 3. What is x? X is the question which we have to find the number of black balls. So we have been able to find out the value of x, that is the number of black balls. This is the answer. Now the question before us is, a jar contains 24 marbles. Some are green and others are blue. If a marble is drawn at random from the jar, the probability that it is green is 2/3. Find the number of blue marbles in the jar. Here we are to find the blue marbles. So let us see what is given in this question. Contains 24 marbles, total number of marbles. These are given as 24. What we are to find out? We are to find out blue marbles. Let number of blue marbles is equal to x. We assume that blue marbles are x in number. So number of other marbles are in green in color. So we here write that, so number of green marbles, because we have already assumed that blue marbles are x. Total number of marbles are also given. All the marbles are either green in color or blue in color. The total of both, that is green and blue, is 24. So when total marbles are given, blue marbles have been assumed. So we can say that the number of green marbles are 24 minus x. So now we can find out the probability of green marbles. Though the probability of green marbles is given in the question, but here we will also calculate the probability of green marbles on the basis of the assumptions of the number of green marbles. So probability of green marbles is equal to number of favorable outcomes. Here the number of favorable outcomes are the number of green marbles. So here we write 24 minus x. It will be divided by the total number of marbles, that is the total number of possible outcomes. So here it is 24. Now as per question, what is given? As per question, it is given that probability of green marbles is equal to 2/3. This is 1, this is 2. This is the what we have calculated probability of green marbles. This is which has been given in the question. Probability of green marbles is 2/3. From 1 and 2, 24 minus x over 24 is equal to 2/3. We can also write it as 24 into 2/3, or we can cut here, divide 24 by 3. Here it comes 16. So we can also write it as 16 is equal to 24 minus x. X will come here on the left hand side and 16 will go on the other side, and here x is equal to 8. That is the number of blue marbles which we had assumed as x. So number of blue marbles is equal to x. This is the answer. Now here in this question, we had assumed that the number of blue marbles are x. Now we will solve the same question with the assumption that green marbles are x. Let us see. what happens? Now, the total number of marbles which we had, which are given in the question, total number of marbles are 24. Now we assume that let number of green marbles is equal to x. In the earlier question, in the earlier, while solving the earlier part, the same part we had assumed that the number of blue marbles are x, but here we are assuming that the number of green marbles are x. So number of blue marbles are 24 minus x. So probability of green marbles is now is equal to number of favorable outcomes. Number of favorable outcomes means number of green marbles. It is to be divided by the total number of possible outcomes or the total number of marbles. This is the first part. Now what is given? Given probability of green marbles is equal to, now the probability which has been given here in the question is 2/3 from 1 and 2. Here it is probability of green marbles, it is also the probability of green marbles, both are equal. So x over 24 is equal to 2/3. We can say that 24 will come here on the upper side, on the other side 24 into t, 2 divided by 3. So here it will be 43 divided by 3. So here it is 16. Here x represents the number of green marbles. Number of green marbles are 16. So now the number of blue marbles. So number of blue marbles are 24 minus x. 24 minus x. Value of x we have calculated as 16. So this is 8. So this is the answer. Now we have calculated the blue number of blue marbles firstly by assuming blue marbles as x, and in the second case assuming the number of green marbles as x. You have seen both the answers. The answer is the same. You can use any of the formula to calculate the number of blue marbles. Now we proceed with the next question. Now a bag contains 5 red balls and some blue balls. If the probability of drawing a blue ball is double that of a red ball, determine the probability of blue balls in the bag. So here what is given? It is given that bag contains 5 red balls. Number of red balls are 5. So here we assume let number of blue balls, we here assume blue balls as number of blue balls as x. So here the total number of balls comes number of red balls plus number of blue balls, 5 plus x. Now we calculate the probability of blue balls and probability of green balls. Probability of blue ball is equal to number of favorable outcomes. Number of favorable outcomes in the case of blue balls is the number of blue balls. It is x. It is to be divided by the total number of balls. It is 5 plus x. So now what is the probability of green ball? probability of red ball? The probability of red ball is the number of favorable outcomes. Number of favorable outcomes are the number of red balls. It is 5. It is to be divided by the total number of balls, and the total number of balls are 5 plus x. So now we have arrived at the probability of blue balls as well as the red ball. Now what is given in the question? If the probability of drawing a blue ball is double that of a red ball, here what is given? Given probability of blue ball is equal to double that of a red ball. Double that of probability of red ball. So what is the probability of blue ball? It is x over 5 plus x. Now what is the probability of red ball? We will fill in the values. It will be 5 plus x. So now what comes? X over 5 plus x, 10 over 5 plus x. We can also write it as x. Here 5 plus x will go to the other side on the upper side. Here it comes 10 into 5 plus x divided by 5 plus x. So here 5 plus x will be here cut. Both sides, upper and lower side, will be cut with each other, and x is equal to 10. So what we have to calculate? Determine the number of blue balls. Here we had assumed that the number of blue balls are x. We have arrived at the value of x. So the number of blue balls are equal to 10. This is the answer before you. Now the question before us is, find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. Suppose there is a coin. So one side of it is head and the other side is tail. So when we toss a coin, it is possible that head may come, or it is also possible that tail may come. So there are two possible outcomes when the coin is tossed. So total outcomes are 2. So probability getting a head is, here when the coin is tossed, the probability of getting a head is only once out of the 2. So probability of getting a head is 1, because either it will be tail or it will be head. So the probability of getting a head is only 1 out of the 2. So total outcomes are 2. So this is the first part. Next is probability of getting a tail. So here you will also see that when the coin is tossed, you may get tail only once. It is quite possible. It may or may not be there, but here the number of times the tail may come out of the 2 is only once. So here we will write 1 on the upper side, and on the lower side we will write 2. That is the total outcomes. Here it is the number of possible outcomes on the upper side, and below the number of total outcomes. So these are the two answers: probability of getting a head or getting a tail. On the upper side we have taken the number of possible outcomes, that is the number of times the head may come, out of the two occasions. So this is the answer of the fifth question. Now the sixth question is, a bag contains red, a blue ball and a yellow ball. All the balls of being of the same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball, red ball and blue ball? Number of yellow ball 1, number of red ball 1. Here it is written red ball, blue ball, yellow ball. Number of red, blue and yellow. Blue ball is equal to 1. So total number of balls click outcomes is equal to 3. So what is the probability that she takes out a yellow ball? Probability of getting a yellow ball is equal to number of favorable outcomes. The number of favorable outcomes in the case of yellow ball is equal to number of yellow balls. Here we will place 1 on the upper side and it will be divided by the total number of outcomes, that is total number of balls, that is 3. Now the second part, probability of getting a red ball. Here the number of favorable outcomes is equal to the number of red balls. Red balls are also 1. It will be divided by the total number of outcomes. Third part, what is the probability of getting a blue ball? Here number of favorable outcomes are 1 because the number of blue balls is also 1. It will be divided by the total number of balls, it is also 3. So it is the answer before you, that in all the cases the probability of getting any type of any color of ball is only 1/3. Next question, suppose we throw a die once. What is the probability of getting a number greater than 4, getting a number less than or equal to 4? First of all, what is die? Die means dice, which is used in playing games. This is the picture of the die, where we may have 1, or on the upper side 2, or here there may be 3, on the lower side there may be 4 or 5 or 6. There are total in all, there are these 6 points on any die. That is the number of appearances are, there may be 1 dot, 2 dots on the other side, 3 dots, or there may be written 1, 2, 3, 4, 5, 6. So the number of possible outcomes in the case of a die are 6. Die is a plural, a singular word for the same object, and dice is the plural word. That is, die is singular, dice is plural. The thing is the same. So now we will find out the probability of getting a number greater than 4. So the total number of possible outcomes, that is when a die is thrown, what are the possible outcomes? There are total 4 outcomes, 6 outcomes. That is, either the die may give result as 1, or there may be 3 dots appearing on the dice, or 4 or 5 or 6. So the total number of possible outcomes are 6. So what is the probability that we will get a number greater than 4? So here we will write the number of favorable outcomes on the upper side, and it will be divided by the total number of outcomes. So what is the total number of favorable outcomes in the case of number greater than 4? we will find that the numbers greater than 4 are these two numbers greater than. So here we will write numbers greater than 4 are 5 or 6. That is, the numbers are 2, 5 and 6. So here the number of favorable outcomes are only 2. It will be divided by the total number of outcomes, that is 6. So the answer will come as 1 over 3. So now the second part of the question. What is the probability of getting a number less than or equal to 2, equal to 4? Numbers, we will first find out the numbers less than or equal to 4. What are those numbers which are less than 4? Less than 4 are 1, 2, 3. 1, 2, 3. And equal to 4 is itself 4. So the number of numbers less than or equal to 4 are 4. These are 4. 1, 2, 3, 4. So the number of numbers less than or equal to 4 are, here you can also find 1, 2, 3, 4. These here first 3 are less than 4 and 4 is equal to 4. So here the probability of getting a number less than or equal to 4 is equal to, here we can also write it as number, here we can use this sign, number less than or equal to 4. It is a sign of less than, it is equal to. So here we will write the number of favorable outcomes, it is 4. It will be divided by total number of outcomes, it is 6. So here the answer will come as 2 over 3. This is the this was the first part and this is the second part of the question. Now the question before us is, one card is drawn from a well shuffled deck of 52 cards. Calculate the probability that the card will be an ace and not be an ace. In our earlier course, we had learnt in detail about what is the total number of cards, what are the owner cards, what are the ace cards, what are the face cards, how many spade cards are there, how many diamond cards are there, how many heart cards are there, and what is the number of black cards, what is the number of red cards. We had learnt about the same in our previous course. You can also go through the same. However, we will now briefly have an overview of the same so that we can arrive at the question, not by just we will have just an overview so that we can solve this question. So let us have the overview. This is the overview, that in total there are 52 cards. This is the total, out of which 4 are ace cards. You can see here that these are 4 ace cards. Then 36 are digit cards. Ace card means which have A on its face. You can see here that it is A. What are the digit cards? Digit cards are from 2 to 9, 2 to 10, because there is no card which has appearing on it as 1. There is no card which has the symbol 1 on its face. So it starts from A there are 4 cards. Then from 2 to 10, there are 9 cards which are again on 4 because these are spades. Then there are diamonds, hearts, club cards. So these are the 4 types of suits. We have learnt it in detail. Then there are 12 face cards. You can see here that king, queen, and jack. These are the 3 face cards, and each, that is the jack, queen, and king, are again 4 in number. That is, each jack card is of 4 types. That is spade, heart, diamond, and club. So in total, these are 52 cards. So what is the question? Here we have been given the question pertaining to ace cards and non-ace cards. So from this picture, you can find out that the number of ace cards are 4. These are 4, which have A on it, little. While the rest all, from here to here, all, these are non-ace cards. So when we reduce 4 from 52, these are all non-ace cards. This is ace cards, this is non-ace cards. So now we will solve the question. One card is drawn from a well-shuffled deck of 52 cards. Calculate the probability that the card will be an ace. So the total number of cards, or the total number of possible outcomes, that is, if we start playing the cards, how many times we will have the opportunity to have card? We will have 52 outcomes. That is, one time it may come A, that is the ace card, then 1, 2, 3, 4, and so on. Any card, king, queen, black color, red color, any can come. So these are total possible outcomes are 52. So what is the probability of getting an ace card? We have calculated that the number of ace cards are 4. So the number of possible outcomes are 4. It will be divided by the total number of total number of cards or total number of possible outcomes, that is 52. So here it will be 1/13. So this is the first part. So what is the probability of getting not be an ace? So we have already found out that the number of non-ace cards, or the number of favorable outcomes in case of not to be an ace, are 48. It will be divided by the total number of possible outcomes. This is given here. So when we divide both sides by 4, the answer will come as 12/13. So this is the answer. Probability of ace cards is 1/13, and probability of not to be an ace is 12/13. Next question. Two players, Sangeeta and Reshma, play a tennis match. That is, there are 2 players involved in the match. One is Sangeeta and the other is Reshma. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability that Reshma winning the match? So now what is given? Probability Sangeeta winning the match. It is given 0.62. We know that if Sangeeta does not win, it means that Reshma has won. That is, one side will win and the other side will lose. So if Sangeeta does not win, it means that the other side, other player has won, that the Reshma has won. So the probability of Sangeeta not winning the match is equal to, here we can write it as Sangeeta winning the match as probability of happening of an event. We can write it as we probability of Sangeeta winning the match is equal to probability of happening of an event 0.62. So here the probability of Sangeeta not winning the match is equal to probability of not happening of the event, that is Sangeeta not winning the match. Here we had written that Sangeeta if wins the match, its probability is denoted by P happening of the event. When it does not happen, here we denote it by this probability of not happening of the event. Then when the Sangeeta is not winning, its probability is here that it will not win. It means that this probability means the probability of Reshma winning the match. So when Sangeeta is not winning, it means that the Reshma is winning. So when the probability of Sangeeta not winning the match is known to us, we can say that it is the probability of Reshma winning the match. So we also know that the sum of probability of two complementary events is equal to 1. We know that the sum of probability of two complementary events is equal to 1. It means that probability of happening of the event and probability of not happening of the event is equal to 1. We have already learnt that the probability of an event always ranges from 0 to 1. If there is probability is 0, it means that the event will not happen at all. If the probability is 1, it means that the event will surely happen. And if the probability lies somewhere between 0 and 1, it shows the varying degree of likelihood of the occurring of the event. So here, probability of happening of the event, that is the probability of Sangeeta winning the match, is known to us. So it represents the probability of Sangeeta not winning the match. When probability of Sangeeta not winning the match is known to us, it means that it is the probability of Reshma winning the match. So we will fill in the value of probability of Sangeeta winning the match. It is 0.62 plus probability of Sangeeta not winning the match, probability of not happening of the event is equal to 1 minus 0.62 is equal to 0.38. So this is the probability of Sangeeta not winning the match. So the probability of Reshma winning the match is equal to 0.38, because we have already learned that when Sangeeta is not winning, it means that the Reshma is winning. When the probability of Sangeeta not winning the match is found out, it means that it is the probability of that the Reshma will win the match. So we have arrived at the probability of Reshma winning the match by using the formula probability of happening of an event plus probability of not happening of an event is equal to 1. So now the next part. Savita and Hamida are friends. What is the probability that both will have different birthdays? And second part, the same birthday, ignoring a leap year. Leap year is a year in which There are 36 days. That is, we take the month of February as 29 days. So now here it is given in the question that we have to count the number of days of the year as non-leap year. That is, we will take the number of days in a year as 365. So what is the probability that both will have different birthdays? Suppose Savita takes birth on 1st January. Total number of days in a year, or the total number of possible outcomes are 365. So when we had to find out the probability that both will have different birthdays, when the Savita has birth of Savita has taken place on 1st January, it means that Hamida can take birth on any day in between or from 2nd Jan to 31st December of that particular, on any day. Number of days from 2nd Jan to 31st December are 365 minus 1, because 1st January has been allocated to Savita, who has taken birth, and Hamida has to take birth not on 1st January but on any other day which falls from 2nd Jan to 31st December. So the number of days on which Hamida can take birth is equal to 364. So this is the number of favorable outcomes for Hamida. So the probability that both will have different birthdays is equal to, here we will write the number of possible outcomes. Here the number of favorable outcomes are 364, because one has to take birth on a separate day and the other person can take birth on any other day excluding that one particular day. So the number of favorable outcomes are 364 for Hamida, and the total number of possible outcomes are 365. This is the first part of the question. Probability of both will have different birthdays. Now, what is the second part? Probability that they have the same birthday. Probability same birthday. Suppose both Hamida and Savita take birth on any particular day. Let us assume, let both take birth on 1st February. So what is the, so there are balance 364 days. We are not to consider that because both have taken place, birth of both the friends have taken place on one particular day. Same birthday will mean that they will take birth on a single day, and we have assumed that it is a single day as 1st February. So what is the number of favorable outcomes? It is only one, because both are to take birth on a single day. So the number of favorable outcomes are 1. It is to be divided by the total number of possible outcomes, or the total number of days in the year. It is 365. So this is the second part, that the probability of same birthday is 1 over 365, because they will not be in a position to take birth on any other day, because birth both birthday of both the friends will take place on a single day, any day of the year. We will have to assume one single day, any day. Next, now the question before us is, there are 40 students in class 10 of a school, of whom 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the name of each student on a separate card, the cards being identical. Then she puts cards in a bag and stirs them thoroughly. She then draws one card from the bag. What is the probability that the name written on the card is the name of a girl or a boy? What is given in this question? Total number of students are given as the total number of possible outcomes are 40. 25 are girls. Number of students. Then what is the number of boys? It is 15. Now what is written more? It is written that the teacher has to select out of these 40 one student as a class representative. He writes all the names on separate cards and mixes the cards, and then one of the card out of these 40 is picked up. We have to find out the probability whether the card which has been picked up will be that of a girl or that of a boy student. Now why we will find out the probability of the that the name written on the card, probability that card will have name of a girl. First we have to find out this, that the card which will be picked out from the 40 cards will have the name of a girl. Here we will write the number of favorable outcomes divided by the total number of we will divide the number of favorable outcomes by total number of possible outcomes. Number of favorable outcomes means the number of girls students. It is 25. It will be divided by total number of outcomes. That is the total number of students. It is 40. So here we will divide both by 5. Here 25 is divided by 5, 5. 40 divided by 5 comes 5, 8. 5 over 8. This is the first part. Now the second part, probability card will have name of a boy. Here we will write the number of boys. Number of boys are 15. It will be divided by the total number of students. It is 40. So here again we will divide both by 5 and the answer will come 3 over 8. So we have arrived at the probability of getting a girl or getting a boy. Now the next question before us is, Harpreet tosses two different coins simultaneously. Say one is rupee 1 and the other is rupee 2. What is the probability that she at least gets one head? So there are two coins, 1 rupee and 2 rupee, and they are to be tossed simultaneously. Let us find out the probabilities. What can be there? It is possible that when the coin first is rupee 1 coin is tossed, it may be head, and when the rupee 2 coin is tossed, it may also result into head. Then it may be possible that the 1 rupee coin gives head and the 2 rupee coins gives tail. It is also possible that the first coin, that the 1 rupee coin gives tail and the second coin gives the outcome as head, it is also possible that both the, that is 1 rupee coin and 2 rupee coin, give the outcomes as tail, both tail. That is when we toss 1 rupee coin, tail comes. When we toss 2 rupee coin, it also gives tail. So these are the 4 possible outcomes, these two coins. So the total number of possible outcomes are 4. Now we have to find out that she gets at least one head. So the number of favorable outcomes are here. From the outcomes we find that here it is given that at least one head, that is head may be at least one or more than one. Here there are two heads, that is first. Here head is also given, head has also been the outcome. Here head is also the outcome. Here there is no outcome as head, that is the number of favorable outcomes are 3, where head has been the outcome either on 2 occasions or at least on 1 occasion. So what is the probability that she gets at least one head is equal to number of favorable outcomes when the outcome is at least one head is 3 divided by total number of possible outcomes. This is 3/4. So this is the answer. Now we calculate the third question. In a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes after she starts playing. We often see in the on the television that there are many small children playing and there are chairs lying and the music plays in the background, and in this question it is given that this music is ringing, is there in the background, and there are chairs lying, and the music may stop at any time up to 2 minutes, in between 2 minutes, that is it may stop at 10 seconds, 20 seconds, 30 seconds, any up to 2 seconds, at up to 2 minutes. So the total time given here, it is 2 minutes. It is to, we know that in normally we arrive at the total number of possible outcomes, and then in normal questions we find out the number of favorable outcomes. Normally in the probability questions, this is the, we are to mention number of possible outcomes, total number of possible outcomes, and the number of favorable outcomes. But if there is the calculation of an area, we will mention total area, then the favorable area. In the case of time, same thing happens. We will mention not total outcome, we will mention total time. Now what is the probability that the music will stop within first half minute? Half minute means 30 seconds. 60 sec, there are 60 seconds in 1 minute, and here half minute is given. So the favorable time here is half minute is equal to 30 seconds. Here we will take it as 120 seconds, because 2 minutes multiplied by 60 will result into 120 seconds. So what is the probability music will stop within first half minute after starting. So here we will write favorable time. It is 30 seconds. Then we will the total time. It is 120. So the answer for us is 1 over 4 because we will divide both sides by 4. So this is the probability of the music stopping within first half minute after starting. So 1 over 4 is the answer before you. Now the question before us is, a missing helicopter is reported to have crashed somewhere in the rectangular region shown in the figure. This is the rectangular figure. And the helicopter has gone missing in this rectangular figure. What is the probability that it crashed inside the lake shown in the figure? That is, what is the probability that the helicopter which has crashed might have landed in this lake? So first of all, we see the figure what is given. Here, the total length of the rectangular region is given. This is 9 kilometers. What is the breadth of this rectangular region? This is 4.5 kilometers. Now, what is the length and breadth of lake? It is not given. We will have to arrive at the same. So, first of all, let us find the length and breadth of lake. Length of lake is equal to, here total length of the rectangular region is 9 kilometer. What is given above? Here you can see that here up to this point, from here to here it is 6 kilometers. Then after that it will be 9 minus 6, 3 kilometers from here to here. It is the length. 9 minus 6, it is 3 kilometers. Now what is the breadth of lake? Let us find out the same. This is the breadth. Total breadth of the rectangular region is 4.5. Here it is given as 2 kilometers. So we will find out this breadth. So we will 4.5 minus 2 is the breadth of the lake, 2.5 kilometers. So 4.5 minus 2 is 2.5 kilometers. So what is the area of lake? It is length into breadth. So it is 3 into 2.5. So now what is, we will have to find out the total area also of the rectangular region. Area of rectangular region. Why we will have to find out the rectangular region? Because here the area of rectangular region represents the total outcome or the total area. It is equal to the total area. Here it represents the favorable area because we will have to find out the chances of crashing of the missing helicopter in the lake. So the area of the lake is the favorable area. The total area is the rectangular region. So what is the rectangular region? It is length into breadth of the rectangular area, 9 into 6. This is the total area of the rectangular region. So what is the probability missing helicopter crashed inside lake is equal to area of lake. This is 3 into 2.5 divided by the area of rectangular region or the total area. It is 9 into 6. So what we will now arrive at, we can here we have arrived at wrong because the area of rectangular region was 4.5. Here it was not this, it was 4.5. Here we have to take 3 into 2.5 into 9 into 4.5. This is wrong. So now what is given before us? 3 into 2.5 into 9 into 4.5. So let us see what we can arrive at. If we multiply both 3 into 2.5, it will arrive at 7.5 divided by 9 into 4.5. If we divide both by 1.5, so here it will come 5 into 9 into 3. So here it will come 5 over 27. Because if here we can calculate that if we divide 1.5, 7.5 by 1.5, it will be 15 into 5, 75. If we divide 4.5 by 1.5, it will be 3 because 15 into 3 is 45. So the answer before us is 5 over 27. We now calculate the next, find out the question of the next answer. Next answer of the next question. Now, the question number 15. A cartoon consists of 100 shirts. 88 are good, 8 have minor defects, and 4 have major defects. So here these are good shirts, these have minor defects, these are 8. So then there are some shirts which are having major defects, these are 4 in number. Jimmy, a trader, will only accept the shirts which are good. Good shirts are 88. But Sujata, another trader, will only reject the shirts which have major defects. One shirt is drawn at random from the cartoon. What is the probability that it is acceptable to Jimmy and it is acceptable to Sujata? So now first, what are the good shirts? Number of good shirts, these are 88. Number of shirts, with minor defect, these are 8. Number of shirts with major defects, these are 4. So the total number of shirts are 88 plus 8 plus 4. 88 plus 8, 96 plus 4, it is 100. So now we will first find out what is that the one shirt is drawn at random from the cartoon. What is the probability that it is acceptable to Jimmy? What is written? Jimmy, a trader, will only accept if the shirt is good. Jimmy will accept the shirt if it is good. So probability, first part we are doing probability that shirt is acceptable to Jimmy. The shirt is acceptable to Jimmy only when the shirt is good. So the number of favorable outcomes for Jimmy are 88. That is the number of good shirts. And the total number of shirts are 100. So here the answer is 0.88. That the shirt is acceptable to Jimmy. Now the second part. What are the chances that it is acceptable to Sujata? So what is the total number of shirts? We have already arrived at total number of shirts are 88 plus 8 plus 4. These were 100. So Sujata will only reject the shirts which have major defects. That is, Sujata will accept the shirts which are, that is, accept major defects. That is, it will not accept these four. Sujata will accept the shirts which are good and having minor defects. So number of shirts acceptable to Sujata are 88 plus 8, that is 96. So probability shirt is acceptable to Sujata is equal to number of shirts acceptable to Sujata is 96. It is to be divided by the total number of shirts, that is 100. So the answer before us is 0.96. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.